So in the previous video, we talked about, multi-platform builds, right?
Yes.
Yes.
Okay. So today we'll see one more optimization technique, that is building various stages parallelly to further improve build speed. Okay. So in what all scenarios we can go for parallel builds. Okay. So this is one of the repository, that is maintained by Docker. And this particular tutorial is already available in official Docker documentation. Okay. So we have, this repository where we have both client and server written in Golang. Okay. So if you see, this is the project structure. So you have, the main Docker file, and then you have inside the CMD, we have both client and server as two separate folders. Okay. And inside it, you have client related code and server related code. Okay. So usually, we need to build this client and server separately as Docker images. Okay, so in that case, we might write two different Docker files, but we will see how to use a single Docker file to build both client and server. Okay, so we will start with a single Docker file, and then we'll try to optimize it with multi-stage builds, and then we'll go for parallel builds. Okay, so we'll see all those different scenarios, okay, including the optimization techniques. So if you want to, know from where I took this particular repositories, so if you just search for Docker build or build with Docker, so you will have this, URL that is build with Docker. Okay, if you just follow this tutorial, you will find a link to the repository. Okay, or else you can just search for Docker samples build me. You'll find this repository. Okay, so inside these chapters, they have various, Docker files. Like you can start with the main Docker file, and what all modifications that we are going to do. These are the various modifications. Okay. And, coming to this task file, this is a separate software basically. Okay. In order to use this task file, you should have the task installed in your system. Okay. So this has nothing to do with your Golang code or anything. So basically this task is a utility, that can read a definition, a configuration from task file.yaml. Okay. So if you see, I have various tasks like go to 1, go to 2, go to 3 and all. Okay. And what exactly it is doing is it is running some shell commands. That's it. Okay. So in case if I have to, run multiple commands, okay, I can define them in the task file, and then I can simply invoke a single task using a task followed by the name of the task. Okay, so that's it. So it has nothing to do with your code or nothing like that. So if I just do task, which is your actual binary, and if I just set to go to 1, so it will actually read this task file, and whatever you mention in this go to 1, it is going to execute. It is just like you have multiple shell scripts, and then you can just call a single shell script anytime. Got it?
It is like makefile, right? Then
Something like makefile, yes. It is kind of alternative to makefile, you can say. Okay, it is doing nothing. It is just taking, each Docker file, and then it is overriding the Docker file at the root of the repository. You can see under the chapters, it is taking various Docker files. Okay, and it is overriding the default Docker file. That's it. Okay, so we don't use this. Okay, that's the reason why once I already cloned this repository. Okay, and then I removed the task file and whatever chapters. Okay, guys, any questions?
Vikram, is this task file related to Docker or Go?
No,
It is
no, it's
common.
not related to Docker. If you see, if I just open this Docker file, right, they just started with a single stage. Okay. So if I have to go for multi-stage, like following that tutorial, I should, go to any of the chapters, just see this second one. It is still the single third one. Okay. It is multi-stage build. Okay. So what I have to do, I have to just copy the data from here, and then I need to overwrite this main Docker file, right?
Yeah.
Correct.
Yes.
So instead of that, what they did is they just gave that same as a task file. And then if I simply run task, go to 4 or go to 3, it is going to read that Docker file and it is going to override your main file. That's it.
Okay.
Got it. It
Yeah.
has nothing to do with anything. Okay. In fact, if you want to do some sort of automation for your projects and all, you can use this task tool. Okay. Now coming to, our example. So we have a client and server. Okay. So if you just see the server code, so whatever it receives from the client, it is going to convert it into, I think it is going to do some conversion. I'm not sure what exactly it is going to convert. Okay, so that is basically about the server. Okay, and server runs on some port. So that port is 3000. Okay, and if you look at the client code, so client has to reach the server on port 3000 and it has to send some text. And whenever server receives that text, it is going to convert and display it. That's it. It's a simple client server. Okay, so we don't have to understand the code. But the reason why I'm explaining this is I'll be, modifying this code a bit. Okay, I'll also show you when this code breaks. Okay. So first thing is, let's see what exactly they're trying to do in this default Docker file. They just took some base image and, set the working directory. They're copying all the data. Okay. Running go mode download, because if you see, we have go.sum and go.mod file. So if I have to explain about the difference between go.mod and go.sum. So basically go.mod will maintain all the dependencies required for your project. Okay. That's the reason in the Docker file, we run go mod download. So what it will do is it will read this go.mod file and it is going to download all the dependencies before compiling your source code. Okay. It is just like your pom.xml. Then what is this go.sum file is? So it will maintain the hashes for all the dependencies that you download. Okay. So the reason why these hashes are required is, if Go has to compare whether to download a particular dependency or not. Let's say if you already have the dependency, so Go, need not download that dependency, right? But how Go is going to decide whether you have the dependency downloaded or not, or whether the dependency which you downloaded is not corrupted or not. Okay. So once you download a dependency, this file gets updated with certain hash value. So what Go is going to do is before downloading any dependency, it will check whether the dependency that it is downloading has the exact hash which is already available in your go.sum. If there is any mismatch in the hash, it will decide that, either the downloaded dependency is corrupted or it is not available. Okay, so this is for the extra security requirements. Okay, that's it. So you don't have to know anything more than that. And if you look at the Docker file, so we are copying everything, running, go mod download to download all the dependencies. And then within the same Docker file, they're building client and the server. Okay. So usually when you do go build, uh, it's a single command. It is going to output the binary file. Okay. So with the same name, I think as the folder name. Okay. But if you want a different name, you can set -o, that is the output. Okay, so what exactly we are trying to do is, so we are trying to build this client folder, which is there in CMD client. And once it builds the binary, we are naming it as client, but we are putting it in the bin directory within the Docker image. So the same is for the server. Okay, so ideally client and server should be built into separate Docker images, but we will see how to do that uh, with this single Docker file. Any questions? And as an entry point, if you see, they're just running the server. Okay. So we have the server under bin. So just invoking the server. Okay. So let me first try to build this without any further optimizations, and I'll tag it as what do you say? Let's say something. Okay, so I'm not interested in the naming conventions. I'll just say go converter. Okay, it says daemon is not running. Let me start Docker. Okay, I need to move to that folder.
Vikram, Go is compiler like Java, right?
Yeah, it's compiled. Not like Java. Java is both interpreted and compiled. Go is a pure compiled language. You don't require any runtime environment like JRE.
Okay. Okay.
So let's say Docker images, we just built something known as Go, right? Okay, so we have Go converter, so which is 416 MB. Okay, so which is quite used because so we are basically using a single stage. Okay, and also we have client and server both available in the same image. So let me run this image. So Docker run -d. Okay, so the name of this is the name, and this is the image name. Okay, Docker PS, it is running. So let me exec into it, -it. So the name of the, this container is server, and I can directly invoke the client, or else if I have bash, I don't have bash. Yeah, I have sh. Okay. So your client is under /bin/client, right? Within the same image. So I'll just invoke it. Okay, so now once you invoke it, so you have this translator message. So once if I start typing and enter, it gives me some value. Okay, I'm not interested in what exactly it is converting, but it is working. Okay, so let me exit and then remove this container. And one more issue with this is, so we have a single image, and this image is occupying a very huge size. Okay, because it is a single stage build. And coming to the other optimization that we already talked about in the previous sessions. So here you're just copying everything in this fourth stage. I mean, in the fourth step. Okay, in the fourth line. But this go mod download will only depend upon this go.mod file. Okay, which usually will not change much often. Okay, but if you change any of the source code, and if you run this copy, it is going to copy new code, but again it is going to download all the dependencies, because so after this copy command, if the copy command changes, so everything after that will have to rebuild. Okay, so this will not use any cache. That's the reason what we will do as the first optimization technique. So first we'll copy only go.mod and go.sum file, so within the current directory. Then we will run go.mod. So it will download all the dependencies. Then I can download the entire, I can copy the entire source code. So what will happen is till this, run go mod download. So it will try to reuse the cache every time you build this Docker file. Correct? Correct, guys.
Yes.
So that's the first optimization technique I can do. Anyways, there won't be any change in the final Docker image size, because we are not using any multi-stage builds. Okay. So now what I'm going to do is I'm going to use multi-stage builds to separate the build and the final artifacts. Okay. So here, where are the final artifacts? So the final artifacts are these, right? Okay. So what I have to do, I have to convert this into multi-stage build. So in the first stage, so you can just call it as, build. So I'm going to take second from instruction. I'll call it as from scratch. Okay. And then I'll copy from the build stage. So what are the binaries that I need to copy? I need to copy into, copy these two, right? Bin client and bin server. So I'm going to put it in any folder. Okay, so already we will have bin folder, right? Within the image, any image will have the bin folder. Okay, so I'm copying your client and server binaries into bin directory of the scratch image. Okay, that's it. Now what I'll do, I'll try to build it again. So this time I'll say go converter instead of latest. I'll say multi. Okay.
Vikram, there is a typo error. Line 3.
Uh,
Copy. Go.mode on go.sum, right? It has to be go.sum.
oh yeah, thanks.
Scratch will be able to run Go binaries. Okay.
No. See, there is nothing like Go binary or C-lang binary. It is a bin binary.
Okay.
Okay. It is dependent on the system architecture. Okay. It will be zeros and ones.
Okay.
Okay. So Scratch is just a minimal image. It can run any binary file. Got
Okay.
it. There is nothing like Go binary. Now let me check all the images, that I created. If you see, we have multi-stage build, which is just 15.9 MB. Okay, which is very less in size. Now let me start the same image. Let me start the similar container like before, but this time I'll use this minimal image that I created. Do Docker PS. It is running. Now I can exec into it. Exec into this server. This time I'll directly invoke the binary. Okay, I don't want to use sh and then call this bin client. Okay, I think because I'm running Windows, it is giving that C drive and all those errors. Sh execute not found. Okay, probably in Scratch. We don't have sh or bin. This is the issue with Windows.
Can we check that build
No
log?
such. No, that log will be there, but the thing is, I'm not able to exec into the program and do call this client. Let me directly call the client if bin is there in the, yeah. Anyways, bin is in the path, right? I can just use client, call the binary. Got it? Right, guys? Clear?
Full path doesn't work.
Yeah, it's not working because that slash, it is not able to resolve in Windows.
Okay.
If you see, it is pointing to my Windows path. I have to fix this somehow. I don't know. I think it will be the issue with all Windows system. It's not only with me, but I have to see. Okay, so we now reduce the size of the image because we have used multi-stage builds. Okay. Now again, if you look at this image, we are building the client first and server second. Okay, server next. So you can again interchange these instructions, like you can build server first and client as a second step, but these are not built parallelly. The reason why these are not built parallelly is, because these are instructions, those gets executed serially. Okay. And here these cannot be parallel builds even though you have from instructions multiple times, because in the second from instructions you have copy from the previous stage. Okay, so which means this stage has to wait. Okay. Now what I'll try to do is I'll try to build both client and server separately. Okay. So for this, what I can do is, see, so what are the common steps for building client and server? It is still this, right? So we need to have the dependencies and also we need to have the, source code. Okay, so for this, what I'll do is, I'll consider this as my common requirement. And instead of calling this as some build, I'll call it as some base. Okay. And I'll say from base. Okay, so image name, I don't have to use capital, so I'll name it as base. So this is a different instruction. So earlier, when we selected from, it is always from a repository, right? Like Docker Hub registry or some registry. But you can also use your own images. Let's say if I have some Dockerfile instructions and if I call this entire stage as base, I can use that entire image here as the base for the next stage, which means this entire image will be now my new base. Got it? Clear, guys?
Yes.
Okay, which means, so let me first write it like this. Got it?
Can't we keep it as a child Docker file?
It is something like this.
Okay.
Okay, so till here it is common. We are calling it as base. I'm taking the base and I'm building client here, taking the same base and building the server here. Got it?
Okay.
Any questions, guys? Okay. And now again in the last instruction, from scratch, so where is client is being built? Client is being built in this particular stage. Okay, so I'll name it as something like build client and build server. Okay, so here from build server okay, so I can just make it as client. So from this stage, okay, so whatever bin client that I'm getting it, I'm putting in the bin directory. Okay, so which means from this particular stage, I'm copying the client and putting in the bin. Again, from the server stage, I'm copying whatever server binary that I generated and I'm putting in the bin. Got it? Any questions?
Vikram, why do we need to have
Which one?
from base two
Because
different
see,
types?
in order to, you're talking about this?
Yeah, correct. Yeah.
Okay, so the reason why I require this is, see, this from instruction and this from instruction. Okay, if you see, these are independent.
Okay.
Both of them are depending on base, which means they will run only when base is completed.
Okay.
Okay, so they don't have any dependency between each other. But this crash has dependency on both, both of these previous ones, like 2 and 3, which means first this will run, these two run parallelly. In the third step, the the binaries will be copied
Okay, so those two will run
parallelly because from instructions are there. If you see, there is no dependency like copy from somewhere. There is nothing like that.
Oh, okay.
Okay, if you see, it has here. And since these are using base, which is mentioned here, this has to be built first. You can
Okay.
see the ordering, like which order they will follow. This is the first one which they are going to do, build. These are parallel ones. And then this is again the last one.
Okay. So once this image is built, can we see the layers and whether it is cached or not?
It will be cached. See, every Docker file, the instruction can be cached. So if you're not, changing any of the instructions, it will always try to use from the scratch. I mean,
I
cache.
got that. I got that. What I was trying to understand is once the image is built, we can see the layers, right, which was created.
Yeah.
So is there a command or something if we can show that after this
Docker
image is built?
image history.
Image history. Okay.
Okay. Now I'll try to build it. Okay. You won't find any difference in the Docker image size. Okay. So I'm just going to build it and I'll say this time parallel.
So
Okay.
we no need to mention something to do run as parallel, right? It has when
No.
there is dependency, it
Yeah.
runs by default as
Because it will look at the from instructions and see if they have any dependencies. If they don't have any dependencies, then it will. If you see here, see build client one by one, build server. See, Both started.
Okay.
So Vikram, if any of these from base fails, whether it's client or server, so we get the image or it
No,
will
we
stop?
don't. It will stop.
Okay, so it's parallel, but it is not that.
Yeah, let's say I just said this is server 2, something like this.
Mhm.
Okay, and if I try to build it,
So Vikram, to my understanding, the first from will run. After that, the second and third will run parallelly, right?
yeah, because they don't have any dependency.
Dependency. Okay.
So they don't have dependency on base, which is already built.
Okay.
Okay, so there is this issue. So let me revert it back and try to quickly build it again.
Vikram, in the
You can
first,
see. Yeah.
In the first Docker file, we gave line number 9 and 10, right? So, I mean, only run, talking about only run commands, two run commands, 9 and 10. Sorry,
Yeah.
9 and 12. So these two will not be also considered as parallel, only the from
No.
instruction.
See, every Docker file instruction that you have should run sequentially.
Okay.
See, here I'm taking different stages. So the stages can be parallel.
Okay, only the
If
stages.
stage has a dependency on previous stage, it cannot be built before the previous stage.
Okay.
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 So now I built it. If you see Docker images, it will still be, even though it is parallel build, it is still 15.9 because ultimately it is packing both the binaries. Okay. Clear, guys? Any questions?
Until it completes the build for both client and server, it will wait, right, from 14th line onwards, right?
Yes.
Okay.
So
Okay.
what's the main advantage of the parallel build against
So,
the multi-stage one?
sorry, I didn't get you.
What's the main advantage of the parallel build?
Parallel builds, it is to speed up the process.
Okay.
See, why should I wait, for the server to build before starting the client? Because both are parallel, both has a separate code base. But the problem here, the reason why I took the base is because both have similar dependencies. So why don't I build the dependencies and create that as a base and provide it as an environment for building client and server so that they can build parallelly.
Okay.
Okay. And still, if you see, we have both server and the client binaries within the same image. Okay, so which I don't like. So what I have to do is, I have to create two different images. Okay, so for this, I'm going to break the final stage into two. Okay, so I'm going to use same from scratch in both. Okay, and since I cannot have this kind of an arrangement, okay, so I can build client and the server separately. For this, I'll name this particular stage as client and this particular stage as server. Okay. So in the client, I'm just copying from the client and then putting in the bin. I'll use the entry point here as a bin client. Similarly, for the server, I'm copying from the server stage and copying into the bin. I'm setting bin server as the entry point for the server. Got it? So of course, we know that if we try to build this, okay, so only the final stage will be containerized. But what about this? This will be ignored. Okay, so till this particular point, I can build one separate image. Till this point, I can build separate image. Okay, so if you have multiple stages, I did not talk about this. I mean, I think I missed it. So let's say you have from some instructions, okay, and again from some instructions. I'm calling this as, let's say, client, and I'm calling this as, let's say, server. Okay, so I can build this particular Docker file, I mean, this particular stays as a separate image, this particular stays as separate image. So if you're doing Docker build, so we know that the final stage will be Dockerized. But if I use something known as -- target, and if I mention the target name as this client, so this particular stage will be built as a separate image. Similarly, Docker build -- target equal to server, then this particular stage will be built as a separate Docker image. Okay. So in my case, since I divided client and server, okay, as two separate images, they have their own, CLIs, I mean, the application and their entry point set. Okay. So what I'll do now is I'll try to build them separately by taking the, the stage names. So Docker build, I'll tag it as go client, and then I will ask it to build till this client. Okay. That is target equal to client. And then I'll put it dot for the build context. And remember, in the latest versions of your Docker, okay, so if I'm trying to build only this client, if you look at this client from instructions, so we are copying from the client, which means we are copying from here. So tell me whether this from instruction will be executed or not.
Yeah, because it's parallel.
It is parallel, but I'm trying to build only till this point. I'm not targeting the server like before.
But
Okay.
it runs in sequence, right?
No, it
It
comes
should.
in the sequence within the same stage, but stages can be sequential or parallel. It will be sequential when you're trying to copy from some stage. They won't be sequential if there is no dependency on the other stage. In this case, they will build parallelly, but Docker, it's smart enough to only build the stages which is required for the final image. Okay. Since my final image only requires a client, and this client is dependent on this stage is dependent on the base, so it is going to only build them. Okay, so let me just try to target the client stage and show you. Okay, so it is there is target stage client could not be found. Which one I used? Oh, I didn't save this one. Okay. You can see it is running that base. And then if you see, it directly went to build client. Okay. But you will never see build server stage. Got it? Clear, yes? So that is the latest advantage with the the BuildX build kit. Okay, so
Even the last stage also will not run, right? I mean, the server
no,
stage.
because we already asked it to build only till this. Okay, now I'm targeting the server stage. Okay, and I'll call it as go server. Okay, so let's see the images. So now images should be exactly divided into half. You can see server is 7.91, client is 7.91, 7.98. Okay, the reason why this is because we divided the images and they have only their binaries. Got it? Clear, guys?
Become the scratch is it just a pseudonym?
No, Scratch is an image. It's not a pseudonym. Like just like from Nginx, we do
Okay.
right. Okay, so Scratch is just one image which is just like a very minimal image. Okay, it will be like 5 MB. I think it doesn't have any tags. I think only one tag is there. Okay, you can just use Scratch. It won't have anything. This image is mostly useful in the context of building base images, like the BusyBox, Debian, and all these, right? They built from
Okay.
scratch. Okay, it won't have
Okay.
anything, but it can run your simple binary files.
Okay, got it. Thank you.
Okay.
So Vikram, in this case, we cannot build the client and server at the same time, right? Creating the image.
No.
So then the purpose of parallel build is of no use then, right?
In this case, it is no use. In
Okay.
case if you have multiple binaries, okay, there it is useful.
Okay.
Okay. So now you have client and the server. So let's first start the server just like before. Let me see. Okay, I don't have anything. So Docker run -d. I'll name this as server. Just start the Go server. Okay. Docker PS. And let me start the Docker run -rn. Let me start the client. So if you see the client, starting instruction, it is bin client. So it will execute a binary. So it is good to give -it because it will expect the interactive terminal and interactive input and terminal because it is asking you to send some input, right, for the conversion. Okay. So let me invoke it. And, it also takes the input. Let's say I'm just trying to pass hello to convert. Okay. But the problem here is what it says, guys,
Not able to connect to server.
not able to connect to the server because earlier both client and server were in the same image. So the server is listening on 3000. And by default, if you look at the client, it always targets the local host. But here there are two containers. They are not local host. They are not, in the same container. Okay, so how do you resolve this? Okay, so either you can take the container name and uh, put it here or the container IP address. Okay, but I don't want to give that as a variable. Okay, so I want to make it configurable, something like you can say environment variables. Okay, so whenever I'm starting the client, I can say where exactly is my server. Okay, so for this, let me check go environment variables, something like that. So let's see how to use environment variables in Go, right? Okay, so they're saying os.getEnv something. So this is what. So I'll go back to my source code. Okay, so and go to this here. So here variable, I'm not hard coding here. I'm just saying get from the environment variable known as host. So whenever I'm just creating this container, I need to pass the host. So host is where your server is running. Okay, so I'll save it. Okay, and this time I need to build the server again, right? Sorry, client again. Correct, guys? Right? Because server is not changed. Server code is not changed. It is the client that changed. Okay, so I'm trying to build the client because this time I deleted that hard-coded value and I'm just using this environment variable host. So now anyways, our server is running. Okay, so the server is running and let me check the IP address of the server. So Docker container inspect server and then grep for IP. Okay, so this is the IP address. Now what I'll do is I'll try to run client just like this. But I'll also pass this environment variable host, which is equal to, I'm saying, so this is your host now. So this is where your server is running. Okay. So try to connect to this server, using this and, let's see how it works. See, actually it did not take that hello because the code is not written like that. It won't take, what CMD that you override. Okay, so it will again open that interactive terminal. So it is giving you the results. Got it? In case if you try to deploy them under the same custom bridge network, so instead of the IP address, you can just use the container name, right? Right, guys?
Yes.
So for example, let me quickly show that as well. So Docker network create. So let's say mynet. Okay. So your server container is running in the default bridge network. So let me add it here. So Docker network, I think it is connect mynet to the server. I mean, connect the server to the mynet. Now, when I try to run the client, okay, I'll give the name of the server container. It is again server itself. And the network, I'm trying to put this also in the same network. Got it? Clear, guys?
Yes.
Any questions?
Even though we are building server and client using target, I would say like two, but we still use single file because it may used in parallel builds in future, right? So is the reason.
Correct. Yes. So why to maintain two separate files? So using the single separate file. Anyways, we'll be maintaining a README documentation, right? So anyone who has access to the repository, they know how to build and build the server and client. After reading your instructions.
Okay. And usually parallel builds are used whenever I want to build a client server model, 2 or 3 more binaries within
Correct.
that page.
Yes. It all depends on the requirement.
Okay.
I just wanted to show you that this exists.